All right, buckle up, because today we're questioning, well, the very foundation of the AI industry's multi-trillion-dollar race for bigger, more powerful models.
Mhm.
They're all trying to build AI with million-token context windows.
Mm.
We're talking Google's Gemini, OpenAI's GPT-4, Meta's Llama, Claude models, all pushing for just, massive amounts of information processing at once.
Right.
But what if this entire race, this fundamental drive, is built on a lie?
It's a compelling question, yeah. And what's truly intriguing is this core idea emerging from new research. Giving AI more information might actually make it, well, dumber.
Dumber, how so?
Imagine models like GPT and Claude. They can ace standardized tests, right? But then they completely fall apart on something really basic, like copying a list of words.
Seriously, just
Just
copy.
copying. This phenomenon is being called context rot, and it could fundamentally shake the foundations of how we build and trust modern AI. It's a pretty big deal.
Okay, context rot. And here's where it gets really interesting. A vector database company called Chroma recently put 18 state-of-the-art models through their paces with a massive, what was it, 194,480 LLM calls?
That's right, almost 200,000 queries to these models, a huge undertaking.
And their discovery. Even the smartest AIs get confused, distracted, and downright unreliable when you push too much information into their context.
Exactly. And the benchmarks we've all been using to evaluate them, it turns out they've been hiding this critical flaw.
So they're not really measuring what we thought they were.
Precisely.
Yeah.
So our mission in this deep dive is to uncover a story the tech industry might not want you to hear. It genuinely challenges everything we thought we knew about AI progress.
And if you've ever felt that frustrating moment where an AI seemed to get confused after you fed it a lot of information.
Yeah, that feeling. What you experienced might not just be user error. It could be a fundamental flaw in how these models operate. And we're going to dig into why that matters to you.
Okay, so to really wrap our heads around how big a deal this research is, we need to talk about the context window arms race, this relentless push for bigger and bigger models.
It's dominated everything for the past couple of years.
Absolutely. The industry's promise has been incredibly seductive. Longer context means more informed outputs. We've seen Gemini 1.5 Pro and GPT 4.1 both hit 1 million tokens.
Llama 4 at 10 million.
Llama 4 at 10 million, Claude Opus also at 1 million with plans for even more. The narrative is, feed an AI an entire code base and it understands your project.
Upload a whole research paper, get nuanced answers.
Give it a legal doc, get comprehensive analysis. It sounds so promising on paper, doesn't it?
It absolutely does, that seductive promise. The expectation was that if you just give the AI everything, it will naturally perform better. But the crucial part, like you said, is what wasn't being truly verified.
Right.
Did these models actually get better with more context, or were they just passing benchmarks designed to make them look good?
Which brings us to the benchmarks themselves.
Exactly. This brings us to the widely used needle in a haystack, or NIAH benchmark. It's been the industry standard for testing long context capabilities.
Explain that one quickly.
Sure, you basically give the model a piece of information, the needle, hidden inside a large document, the haystack, and you just ask it to find it.
Find the specific thing.
Yep. And companies like OpenAI, Anthropic, Google, they all tout their near-perfect NIAH scores as proof of long context mastery.
But the researchers at Chroma had a critical insight. They realized NIAH only tests simple lexical retrieval.
Which means
It's just finding exact words or phrases. It's basically like gauging reading comprehension by asking someone to play Where's Waldo?
okay. Not real understanding.
Exactly, instead of asking them to actually understand and analyze what they've read. So Chroma designed something different, something unprecedented, that massive test. 194,480 LLM calls across 18 top models.
And this wasn't just about finding needles.
No, it was about whether AIs could truly understand, reason about, and actually work with long contexts in a practical sense.
Okay, so what did they find? The shocking discovery.
Well, the shocking discovery from this unprecedented testing was that every single model, including the big names like Claude Sonnet 4, GPT 4.1, Gemini 2.5, they all showed consistent performance degradation as the context length increased.
Degradation, so worse performance.
Worse performance, yeah.
Yeah.
Even on tasks that should have been trivial.
Wow. So connecting this back, while AI companies are celebrating these benchmark wins and charging premium prices for long context,
Their models are actually getting worse at the tasks we users most need them to do.
that's a fundamental disconnect, a really big one.
So what did this testing actually uncover? Let's dig into the 4 shocking ways AI gets dumber with more context. The first one, and maybe the most troubling, is semantic understanding collapses.
Right.
This isn't just about missing keywords, it means the AI struggles to grasp the meaning of information as context grows. Why is this particular finding so significant for how we use AI?
Oh, it's hugely significant because real-world applications rarely involve perfect keyword matches, right? You're not usually just searching for an exact phrase.
True.
So when the questions required interpreting meaning rather than just matching exact text, model performance absolutely cratered with longer contexts.
Cratered, like fell off a cliff.
Pretty much. As the needle question similarity decreased, meaning the questions needed genuine understanding, not just finding the same words, performance degraded dramatically as the input got longer.
Okay, so it reflects real life better. When you need actual understanding of complex points in a big document.
The AI simply loses its grasp on the meaning. It gets overwhelmed or confused by the volume.
That makes perfect sense.
Right.
Now, on to finding two, what the research calls the distractor disaster. This one sounds like it could explain so many frustrating AI interactions I've had.
It absolutely can. I think this will resonate with a lot of people. This finding reveals that even a single piece of incorrect but topically related information significantly reduced performance.
Just one piece.
Just one. And this effect got worse as context grew longer, amplified.
Give me an example.
Okay, imagine you're trying to get an AI to analyze a complex financial report. Now, picture someone slipped in a few pages of numbers from a different company, maybe last year's numbers, that look kind of similar, but are totally wrong for this task.
Okay, irrelevant stuff mixed in.
Exactly. What Chroma found is that the AI doesn't just ignore those distractors, it gets actively confused. It might even confidently give you the wrong, irrelevant data back.
Seriously. Confidently wrong.
Confidently wrong. It's almost like it's saying, oh, you gave me more information. Great. Now I can be wrong with even more conviction.
Wow, that explains a lot. You think you're helping by giving it more comprehensive info.
And instead you get confused or contradictory responses, not better ones.
Yeah.
Helpful input leading to active misinformation. That's alarming.
It really is. Okay, but this next one, finding three, structure makes things worse.
It truly blows my mind. It feels so counterintuitive.
It is totally counterintuitive. How can organizing information carefully actually hurt performance? What's the thinking behind that?
Yeah, this was perhaps the most surprising finding. Structural coherence consistently hurts model performance. Models actually perform better on randomly shuffled text.
Randomly shuffled.
Yeah, than on logically organized, coherent content, text with sections, headings, a logical flow.
That makes no sense.
I know. Think about it. You meticulously organize information to help the AI understand your project, right?
Yeah, of course.
But this research suggests doing that could actually make the AI perform worse than if you had just dumped everything in randomly.
Why, though? What's the hypothesis?
The researchers hypothesized that the way attention mechanisms in these transformer models work, they focus on nearby words.
Right, local context.
Exactly. And that focus might inadvertently distract them from seeing the crucial connections across a long, structured document. It's like the structure itself becomes a hindrance to long-range information retrieval and reasoning.
So the AI gets lost in the trees and can't see the forest because the trees are too neatly arranged.
That's a pretty good analogy, yeah. The local structure interferes with the global understanding.
That's wild. Okay, and finally, and maybe the most damningly, finding four, even trivial tasks break down. We're talking basic text replication here.
Precisely. Just copying text. Models failed at basic text replication as context length increased.
How badly?
When asked to simply copy a sequence of repeated words, performance degraded with longer contexts. Get this. Claude Opus 4 even refused some replication tasks, flagging them as potentially risky.
Refused to copy words. Risky.
Yep, which is quite telling, isn't it? And Claude Sonnet 3.5, an older model, actually outperformed newer, larger models on these basic tasks that, a child could do perfectly.
So if an AI can't reliably copy text when you give it more context, how can we possibly trust it with complex analysis or coding or critical decisions when we feed it comprehensive information?
That's the million-dollar question, or maybe the trillion-dollar question here. It really makes you rethink foundational reliability.
Okay, these findings aren't just technical footnotes. They could reshape the whole AI infrastructure landscape. And they actually seem to vindicate technologies some people thought were maybe, on their way out.
You mean argy?
Exactly. For the past year, maybe more, there's been this heated debate in the AI community. Is retrieval augmented generation, RG, just a temporary fix until we get really good long context models?
Or is it a fundamental architectural choice? It's been a persistent question, absolutely.
And this research seems to tip the scales.
You're spot on. What's truly impactful here is that the context route research basically settles that debate, or at least heavily leans one way.
How so?
The findings strongly suggest that RGA approaches, where you retrieve specific, relevant information from external knowledge base to give to the model just when it needs it.
Instead of stuffing everything in up front?
Right. That RAG approach may indeed be more reliable than just trying to cram everything into these massive context windows.
So vector databases,
Yeah.
external retrieval systems, they become essential.
Essential infrastructure, yes, not just temporary solutions.
Mhm.
And this has really serious implications for enterprise AI deployments.
Talk about that.
Well, think about common scenarios where accuracy is absolutely critical. Legal document analysis,
Yeah, I get that wrong.
code review across huge repositories, financial report comprehension, technical documentation understanding. In all these cases, if the models get confused and unreliable when you give them more information,
Which is exactly what you'd want to do in those cases.
exactly, then those enterprise AI deployments might be fundamentally unsound. You'd literally be paying for capabilities that actively degrade when you try to use them as intended.
Okay, the research also talks about something called context engineering. What's that?
It's basically the careful construction and management of a model's context window. It's about how you present information, which seems to matter more than simply whether it's present.
And it sounds like developers are already figuring this out, doing workarounds.
Yes, they are, definitely. Developers are already using strategies like regular summarization to kind of reset the context.
Starting fresh periodically?
Right. Or strategic information ordering, deliberately structuring content in specific ways, building up context incrementally instead of all at once.
But wait, if they're doing all these workarounds,
Well, that's the point, isn't it? At a deeper level, these workarounds fundamentally admit the problem. If you need all these elaborate strategies to make long context models work reliably,
maybe long context isn't the magic bullet we thought it was.
exactly, which suggests a powerful resurgence for external retrieval systems. For ARIS, if models can't reliably process long contexts themselves, then smart targeted retrieval becomes absolutely essential.
So companies betting everything on just bigger context windows.
They might find their core value proposition undermined, while those building robust retrieval and context management systems could see their approaches validated. It's a big potential shift.
This context-wrought research doesn't just expose current limitations then, it paints a picture of a fundamentally different future for AI system architecture.
I think so.
While AI companies are racing towards 10 million, maybe even 100 million token contexts, this research suggests we might be optimizing for the wrong thing entirely.
Right. Instead of just asking, how much context can we cram in?
Perhaps we should be asking, how can we make context processing more reliable and effective?
I think that's precisely the pivot we need. The new vision for AI systems that this research points to is one where models know their context limitations and work effectively within them.
How would that work?
They'd use external retrieval strategically, rather than trying to ingest everything directly. They'd employ maybe hierarchical context management, and they'd prioritize context quality over mere quantity.
Quality over quantity. That leads to what you might call the context quality revolution.
Yeah, I like that term. Instead of these vague claims of infinite capacity, we might see models optimized for specific context lengths, but with guaranteed performance characteristics.
So you'd know what you're getting. Like, this model can reliably handle X tokens with Y performance.
Exactly. Predictable reliability. That's the goal.
So what does this mean for AI company strategies then? It seems like it suggests a big shift.
It absolutely does. A significant shift, emphasizing reliability over sheer capacity, transparent performance characteristics.
Being honest about limits?
Yes, honest acknowledgement of limitations and better integration with external systems like vector databases.
It also seems to point towards a more hybrid future.
Definitely. A hybrid intelligence future where the most effective AI systems will combine multiple approaches, traditional LLMs for the reasoning and generation they're good at,
Vector databases for the precise information retrieval.
context engineering for optimal information presentation, and importantly, monitoring systems to detect when context degradation is happening.
This feels like a real maturation moment for the AI industry.
I agree. The bigger is always better phase might be ending, or at least it should be, replaced by smarter is better approaches that acknowledge these real-world limitations.
And for enterprises using AI.
It means investing in AI infrastructure isn't just about buying access to the latest, biggest model. It's about building systems that can work reliably with AI's actual capabilities and limitations.
And the most important thing underlying all this.
Transparency, absolutely. This research really drives home the critical need for transparent, real-world evaluation of AI capabilities. The era of benchmark gaming, just optimizing for a specific test like NIH, it needs to end.
We need evaluation methods that truly reflect actual use cases.
Not just artificial ones. We need honesty about what these systems can and can't reliably do.
All right, let's get practical. Whether you're a developer, an enterprise decision maker, or just an AI enthusiast listening.
Ooh.
What does this context-wrought research mean for how you should think about and use AI systems right now?
Okay, yeah, let's break it down.
For developers, the guidance seems pretty clear. Be skeptical of those long context marketing claims.
Very skeptical. Don't just assume bigger is better.
Design your systems with context management in mind from the start. Use retrieval systems like RAG strategically rather than trying to stuff everything in.
And monitor. Monitor AI performance as context length increases in your specific application. Implement context reset strategies if you have long workflows.
This really makes me rethink how I've been prompting models for months, just trying to give them more.
It should. And it leads directly to crucial context engineering best practices. Think about presenting information in an optimal order. And structure, even though structure can hurt, maybe certain structures help. We need to learn more.
Remove the junk too, right? The distractors.
Absolutely. Actively remove irrelevant information that could act as distractors. Use chunking strategies for large documents. And again, implement performance monitoring across different context lengths to really see what's happening in your use case.
Okay, now for enterprises, what's the advice?
Evaluate AI solutions based on real-world performance tests that mirror your actual use cases, not just the vendor's benchmark scores.
Don't trust the marketing hype alone.
Exactly. Budget for context management infrastructure, things like vector databases, monitoring tools. Plan for hybrid AI architectures that combine multiple approaches.
And implement testing protocols that really reflect how you'll use the AI.
Precisely. Test it under the conditions you'll actually deploy it in.
And if you're investing in AI, building or buying solutions.
This research suggests prioritizing systems with transparent performance characteristics. Look for solutions that integrate well with external data sources. Favor platforms that focus on context quality over just quantity.
And look for vendors who are actually honest about these limitations.
Yes, vendors who acknowledge and address these challenges rather than pretending they don't exist. For the broader AI industry, really, this research should be a wake-up call.
A wake-up call for more honest evaluation and marketing.
Definitely. Because the current gap between benchmark performance and real-world capabilities, well, it frankly undermines trust in AI systems long-term.
So what's needed next? Where does the research go from here?
Well, we need more real-world evaluation protocols, for sure. Deeper research into why context rot actually occurs at a fundamental architectural level.
Understanding the mechanism.
Right. We need the development of truly context-aware architectures, models designed with these limitations in mind, and just a better understanding of optimal context management strategies, what really works best.
My advice: treat this context-wrought research as essential reading if you're working with AI systems.
Absolutely. Understanding these limitations isn't pessimistic. It's incredibly practical. It's far better to design systems that work with AI's actual capabilities.
Than to be surprised by failures once they're in production.
Exactly. Context-wrought research represents more than just a technical finding. It's a crucial reality check for an industry that has, let's be honest, prioritized impressive demos over reliable real-world performance sometimes.
So the future of AI might not be about models that can process infinite context,
but about systems that understand their limitations and work effectively, intelligently within them.
So what does this all mean for you listening? Sometimes the most important research isn't about what AI can theoretically do, but about what it actually does when you put it to work.
That's a great way to put it.
The conversation about context rot is really just beginning, and it's going to reshape how we build and deploy AI systems. As you think about this, maybe consider, what other AI capabilities might be hiding similar performance gaps beneath the surface? What else aren't the benchmarks telling us?